Hi, I'm Chris from the International Council on Clean Transportation, and I'm here to explain something called indirect land use change, often referred to as iLUC. Recently, it seems impossible to talk about biofuels without getting drawn into a discussion about sustainability, and in particular about the phenomenon of indirect land use change. Questions about indirect land use change are questions about where the feedstock used for biofuels comes from, and there are essentially three options for this. You could increase the consumption of feedstock for biofuels by reducing the amount available for other uses, including food for humans. You could increase the amount of agricultural products available from existing agricultural land. Or thirdly, you could produce more feedstock by using additional land. The first of these three possibilities gives rise to the food versus fuel debate. While this is important, we're not going to talk about that today. The third possibility, increasing the area of agricultural land being used, is indirect land use change, and it can be a problem for the environment because it can involve a loss of biodiversity and a release of carbon dioxide. Several groups have attempted to model these indirect land use change effects. This involves laying out a scenario for the balance that will occur between reduced food consumption, increased production on existing land, and expansion onto new land. Most of these efforts use computable economic models that predict the way that increased biofuel demand will affect the wider economy. These approaches can consider a wide range of economic interactions, but can be difficult to follow. Today, we're going to talk through the results of a different, causal descriptive approach, based on work done for the UK government by the consultancy E4Tech. Rather than use a computer to predict results, E4Tech have described what they believe will be the most important market responses to increased biofuel demand. The ICCT doesn't endorse this approach or E4Tech's specific numerical results. However, it does provide a useful example of the type of relationships that cause iLUC in the different scenarios. We're now going to work through their prediction for what will happen in the case of increased British demand for biodiesel from oilseed rape. We start off with the world as it is at the moment. Into this mix of various agricultural commodities being used for food, feed, fibre, for cosmetics. In Britain, we add an additional demand for oilseed rape biodiesel. The first response to this will be an increased production of oilseed rape within Europe as a whole. This increased production can result from either increasing the yields on existing land, which can be done through adding more inputs, things like fertilizers and potentially pesticides, or possibly through innovation, increased investment in R&D, the adoption of better technologies. The increased production could also occur by an expansion in the planted area devoted to oilseed rape. It is this type of expansion in planted area, coming as a result of an increased demand for feedstocks for biofuels, that we refer to as indirect land use change. And depending on the type of land where the expansion occurs, it could have significant consequences for carbon emissions, both from the loss of the biomass stored on the land, whether as trees, as roots, as other plants, and also the loss of carbon from the soil. Of course, in a global market, it's not only going to be in the European Union that we see effects. E4Tech identified the Ukraine as a possible marginal producer of oilseed rape for import into Europe. So again, in the Ukraine, just as within the European Union, we expect to see increased yields. That could be due to increased use of inputs like fertilizers, or it could be through innovation, the application of best practice, and potentially more funding of research and development. E4Tech also predict that you'll see the displacement of rapeseed oil out of the Ukrainian food market in order to supply it to Europe. Of course, this means that the Ukrainian food producers will need to get an alternative oil, which E4Tech suggests will be supplied from Malaysia and Indonesia. That's because there will be an additional demand for palm oil for these food applications, and these are the world's leading producers of palm oil. Of course, as before, we will expect to see increased yields of palm oil and also potentially an area expansion. Historically, a great deal of palm oil expansion in Indonesia and Malaysia has occurred at the expense of primary or secondary forest, and in areas such as Sarawak in Malaysia and Borneo, where forest governance is relatively weak, we might expect to see deforestation and particularly high carbon emissions from indirect land use change. Now, back to the Ukraine, where as well as increased yields and substitution out of the food market, we'll expect to see an area expansion as well, which could of course also be associated with carbon emissions. And it's not only the Ukraine that could be supplying additional oilseed rape into the European market. E4Tech predict that you will also see increased imports from Canada. And again, this can come through some combination of an increase in yields and the expansion of the planted area with potential associated greenhouse gas emissions. So that's where our additional oilseed rape is expected to come from. But as well as the vegetable oil that you get from cultivating oilseeds, there is also production of rapeseed meal, and that rapeseed meal can displace animal feed. This might mean a displacement of feed wheat grown within Europe itself, but it might also mean, because rapeseed meal is a high protein feed, the displacement of soy meal produced in Brazil and Argentina. The story doesn't end there either, because a reduction in the planted area of soy implies that we now have less soy oil on the marketplace. So again, to compensate for this, we might need an additional supply of palm oil, and this will have those same effects that we talked about earlier, a potential yield increase, but also the likelihood of expansion into perhaps heavily forested or heavily biodiverse areas. Now, we've just looked at potential increase in land area in Europe, in the Ukraine, in Southeast Asia, and in Canada, all of which could be associated with increases in carbon emissions. We've also talked about the displacement of feed wheat and soy in Europe and in Brazil or Argentina, which could result in less land demand and actually reduce carbon emissions. So, in the E4Tech analysis, what does this mean for the carbon emissions coming from your oilseed rape biodiesel? Well, E4Tech present us with 6 different scenarios with slightly different parameters, and the emissions that they predict range from about 15 grams of carbon dioxide per megajoule to about 35 grams of carbon dioxide per megajoule. And this could be a significant reduction in the savings delivered by those biofuels. Now, as I said at the start, the ICCT doesn't endorse E4Tech's conclusions. There are a diverse range of carbon emissions predictions out there in the literature, and this one is not necessarily better than the others from things like computable general equilibrium modelling. What we have, however, seen is an example of the type of relationships in the world economy that mean that an increased demand for an agricultural product in one country can lead to land use change and potentially to carbon emissions all the way on the other side of the world. You can find out more about indirect land use change by going to the ICCT website, www.theicct.org/fuels.